Hello there. In this video, we're going to go over, by this time you should have gone over the parts of the heart, blood flow through the heart. Now we're going to talk about the cardiac cycle and basically how blood and why blood moves through the heart, from the atrium to the ventricles and the ventricles out. So here you're going to notice on these two objectives you have um, lots of volumes and terms that you need to know the definitions of. So make sure you're doing that. The problem with them, what makes them difficult, is they have very similar definitions, so you need to make sure that you're very clear on each of them. Okay, so we're going to talk about the cardiac cycle, and that's when the muscle starts contracting to the beginning of the next contraction. So the atrium are going to contract, the ventricles are going to contract, then the next cycle starts. Systole means to contract, so when you hear the term atrial systole, that means it is contracting. Ventricular systole means they are contracting. Diastole means to dilate or resting. Atrial diastole and ventricular diastole. Now, the word resting is not a good thing to use, not the best thing to use. When something is in diastole, when the atrium and diastole, they are open and not contracting. What is happening is during that diastole, they are filling with blood. Same thing with the ventricles. When they're in diastole, they are filling with blood. You'll note as we go through this that the atrium and ventricles are not in systole at the same time. So one is contracting, the atrium are contracting in systole, the ventricles are in diastole, and they are filling with blood. When the ventricles go into systole, they are contracting, the atrium in diastole, and they are filling with blood. Now, when we get through this, and I'm going to give you a hint here, all this terminology, we're not talking about the atrium. So if you're looking at a multiple choice test, which you will be, if there's a definition or there's a term and I want the definition, atrium are not in the definition. They are important, but they are not near as important as how efficiently or well the ventricles are working. So when you see the term systole and diastole by itself in a textbook or anywhere, they are talking about the ventricles. They are talking about, if they just say in the heart or their systole is going on, then we are talking about the ventricles, not about the atrium. Okay, so this is just a picture of the process of a cardiac cycle, and you'll notice the blood here deoxygenated on the right side, oxygenated on the left. You got your atrium, your ventricles. You also see the valves. The valves are going to be critical to this process working well and to it being able to exert a pressure that gets the blood to move throughout the body, especially on the left side or for the left side of the heart. So blood's going to flow from an area of high pressure to low pressure. And there are two ways that we can change the pressure in a chamber. And I want you to think about a balloon. If you take a balloon and blow it up with air, if you squeeze that balloon, or let's say the balloon is made of cells, if you contract those cells and they get shorter, then what's going to happen is you're going to decrease the volume of that balloon and you're going to increase the pressure. The chambers of the heart will do the same thing. The heart muscle cells will contract. That will squeeze the chamber, make it smaller, decreasing its volume and increasing its pressure. The other thing that will change the pressure are the valves. You think about that balloon, and if you take the opening of the balloon where you blew the air in, if you hold that closed tightly with your fingers and thumb and you squeeze it, then because that valve is closed, it will increase the pressure in that balloon as you contract it. If for some reason you lose your grip on the balloon as you squeeze it, but if the valve opens, then you don't increase the pressure. So this is one of the reasons that valve health is so important. The valves have to open and close at the right time. If they open too soon, you can actually not exert or get enough pressure in the ventricle, specifically the left one, and that means you can't get enough blood flow out to the body. The balloon example I just gave you that, I will also show you that in class. Okay, so blood's going to come, you got to know your anatomy here, it's going to come from the vena cavas, superior and inferior, into the right atrium, and from the lungs into the left atrium. So we're kind of right here in this drawing. Okay, so we're going to start atrial systole. They will start to contract. The ventricles are in diastole. So as the atrial heart cells contract, the volume's going to decrease, the pressure's going to increase, and that's going to move blood into the ventricles, which again are in diastole. Okay. So blood flows to the atrium, to the ventricles, because the pressure in the atrium is, your answer should be it's higher than in the ventricles because blood flows from high to low. Why is the pressure higher in the atrium? Because the atrial muscle is contracting, again decreasing the volume of those atrium. That's going to increase the pressure. It's going to open up the tricuspid and bicuspid valves and let blood flow through. So we have a volume here that you need to learn. It's end diastolic volume. It's the volume in the ventricles at the end of ventricular diastole. So when ventricular diastole ends, when the filling of those ventricles ends, the amount of blood in them is called end diastolic volume. Again, definitions here. Atrium is not part of this definition. It deals with the ventricles. Now I'm going to put this question up here, but I'm not going to give you the answer in the video. We will do it in class. So the question is, end diastolic volume, is it the same on the left and right side of the heart? And think about why you're answering the way that you are. But again, we'll do it in class. All right, so now the ventricles are filled with blood. The ventricles are going to start to go into systole. This is going to close. Here I use the term AV valves. It's the tricuspid and the bicuspid valve. So you'll notice here that when these start to contract, it's key that these valves stay closed. So as those ventricles start contracting, one reason it needs to stay closed is to increase pressure. The other reason it needs to stay closed is so the blood flow doesn't go back into the atrium. We want it to go out either through the aorta or the pulmonary artery. So what happens to the pressure in the ventricles as it starts to contract? It's going to go up. So when the pressure in the ventricles becomes greater than the pressure in the pulmonary artery or the aorta, then these valves open, your semilunar valves open, and blood is going to flow again either out the aorta to the body or out the pulmonary artery to the lungs. Another term, isovolumetric contraction, a point during ventricular systole when all the valves are closed. So right here, that's when you're going to get that pressure because you're squeezing the balloon, but all the valves are closed, and that's going to increase the pressure in the ventricles to the level that they need. Ventricular ejection, another term, period of time that blood flows from the ventricles. This is a time, so how long? And that's going to depend on the health of the valves. If the valves are healthy, then the ventricular ejection will be a proper amount of time that they are open. If they are unhealthy, if they're stiff and don't open, or they open too soon, then that's going to change the time period and the amount of blood that can get to the body or to the lungs. All right, so the next question is the pressure generated by ventricular systole the same on each side of the heart? I'm going to give you that answer, and the answer is no. The pressure is not the same on both sides of the heart. The left side is much greater than the right side, but I want you to think about why. What causes that, and why do you think the pressure is different on both sides? Why is it not the same? See if you can come up with an answer. I'll give you a hint. Think about where those sides of the heart are sending blood to. More muscle on the left side. I kind of gave you the answer there. And then ventricular systole ends, and then the cycle starts again. So the ventricles release their blood, and then they go into diastole, and the atrium go into systole. And systolic volume. I'm not going to give you that on here. Again, I want you to think about it. I've given you the information you need. You can eliminate a couple of these. And then I've given you a definition of another term that should help you determine what the answer is. Okay, so this is my, as simple as I can get it, because I can't draw very well, representation of this process. So atrial systole and ventricular diastole. These are the atrium. These are the ventricles. See if you know who that is. It's an old, you guys are probably too young. You probably weren't born yet when the show came out, but it was one of my favorites. I actually had a windsock in the shape of that character. So here's your atrium going into systole. So what's happening? That's pushing the blood into the ventricles. The ventricles are in diastole. They are filling with blood. Okay. And then now that the ventricles are filled with blood, what's going to happen is they're going to go into systole while the atrium are in diastole. So the ventricles squeeze, that moves the blood out from the right side to the lungs, from the left side to the body. Okay? And that is basically the cardiac cycle. So you just need to go through it. We'll review it in class. I'll answer any questions that you have. All right, this will be the start of another video.